Hi, this is Dr. Jed. Welcome to the video. Right now, we're going to do evaluation of limits using algebra. First, I'm going to talk about the concept of what we're doing, just so you can see why. And then, we'll do some examples. So, before this, we've used numerical methods, making tables to try to figure out how to do the limit. The trick now is we're going to use a little bit of theory. So, to refresh our minds, if f is a continuous function, the limit as x goes to a of f of x is, well, what is it? You could just plug in. If it's continuous, you could just plug the a in, and you get f of a. So what does this mean in terms of limits? It means if you have something here that's continuous, there's nothing to do except evaluate it. So what's an example of a continuous function? A continuous function might be something like x squared plus 1 over x squared plus 3. There's no places this has problems. Another example might be x sine x, and that's good. But what's an example of something where it's not continuous? Suppose you want to take the limit, say, of x minus 2 over x minus 2. Now, if you look at this, maybe your first thought is, well, that's just 1. And that's the sort of thing we're going to do. But if I plug 2 into this, I get 0 over 0. And 0 over 0 is an indeterminate form. This function is not continuous at 2. In fact, it doesn't even exist at 2. So we can't do anything by plugging in 2. But if we cancel, then it is continuous, and we've avoided the problem. That's the idea we're talking about. So that's the concept. Let's do an example. One actually kind of like this. So we want the limit as x goes to 3 of x squared minus 6 over x squared plus x minus 12. Now, this is a rational function. Rational functions are continuous everywhere the bottom is not 0. So let's take a look. If I put 3 in there, 3 times 3, 9, plus 3 is 12, minus 12, uh-oh, it's 0. So if you just plug in 3, that gives us 0 over 0. Actually, try it out just to confirm. That's 0, 0. And so that's a unhappy face. That doesn't work. So here's the thing. If I can do a little bit of algebra, so it's no longer going to be 0 on the bottom, then I can plug it in. So what I'm going to do, I'm going to rewrite this, and I'm going to factor it. Now I know 3 makes it 0. That means, since the top is a polynomial, that means x minus 3 is one of the factors. Now, if it's a really big polynomial, you could do some long division to get it, but this is a quadratic, so quadratic is actually pretty easy to calculate. And likewise, the bottom is a quadratic. It factors very nicely. It was also 0 at 3, so all we have to do is figure this out. Literally, this is the same as this. But what happens is, at 3, this is 0 over 0. But everywhere else, we can cancel. So the algebra we do is to cancel out the common factor. Now, you can't just cancel out a term. We could not cancel this x squared next to x squared, because those are not multiplied in. But here, x minus 3 is multiplied in, so we can cancel that. We get x goes to 3 of now, x plus 2 over x plus 4. And notice, this is now continuous at 3. There are no problems at all. So we can just plug in. So that's 5 over 7. And that's our answer. That's exactly how easy it is to do these kind of problems. It's a lot better than doing it in a table. At least I think so. Tables are fun, they're big, this is faster. Let's try one that's a little trickier, because that one, I deliberately gave you an example that works out pretty well. What if you have something that's a little scarier, like square roots? Well, does this factor? Well, first of all, if I plug in this case, 1, what do I get? 0 over, square root of 1 is 1 minus 1 is 0. So that's also bad. So that means we have to do something. We have to do some algebra, hopefully, to figure it out. Not everything can use algebra, but most of the ones do. and you'll learn to recognize what does and what doesn't. So what do? I need to figure out how to factor this. So, the top can theoretically factor into two pieces, but when you have a square root, it's tricky. So what I'm actually going to do, instead of factoring the top, is I'm going to multiply the bottom to get rid of the square root. The thing you multiply by when you have square root of x minus 1, it's the conjugate of this. So we multiply by, let me write it first, x minus 1. I multiply by the conjugate, which is the same thing but with a plus sign in between. Now, of course, I could then just cancel that, but that defeats the purpose. So what do I want to do? I want to multiply. What do I get at the bottom? I get square root of x times square root of x, which is x. I get square root of x plus, or times 1, so plus square root of x. I get minus 1 times square root of x. And I get minus 1. Hopefully you can see now why I did this. I did this because the middle terms there will cancel out. What about the top? I could multiply the top out. It's usually a bad idea. I usually wait to see if I really need to. Because what is this bottom? Let me multiply the top out, or not multiply it out, just rewrite it. I have x minus 1 on the bottom. Notice what happened. By not multiplying this through, I now can see immediately, I can cancel like that. At 1, I'm going to have 0 over 0. But if I cancel, what do I have left? I have square root of x plus 1 over just 1. It's gone. The problem's gone. I can now plug 1 in. I get 1 plus 1 over 1, which is 2. And if you did it with a table, you'd come up with the same answer. Hopefully this gives you an idea how to try it. Do some practice, you'll find out it really is a good way to do limits. Until next time.